Here it shows that each element has its own particles property. For example, sulfur is yellow and is shaken with water, it will tend to float. Iron is black and magnetic and will produce hydrogen when you place in the acid. If two elements are mixed together, a gray-black powder is produced. The color depends on the amount of sulfur mixed with the iron. Although the two elements are close together, their property do not change. If the magnet is passed over the mixture, the iron particles lift out and stick to it. If the mixture is shaken with water, the sulfur will tend to float. Okay. It means that you can separate easily. Another example will be if you mix the red bean together with the green beans, you can pick up also easily to separate the green from the red. This is so called a mixture. However, can you see when you have the compound, the story will be different. If the mixture of iron and sulfur is heated, if you put on some heat, a chemical reaction will take place. The atom of iron and sulfur join together to form a new thing, a new compound. We call it a compound. Which is called iron sulfate. It does not have a yellow color in the sulfur or the magnetic property of the iron. So the iron or the original property of the iron, which is magnetic, is lost now. And the yellow color of the sulfur also lost. Now a new property, a new thing, everything is new. It's a black non-magnetic solid. All compounds have the property that will differ from the element that form them. When iron and sulfate react together, they form a product called iron sulfate. And now you cannot return it just like you see in the water, using a magnetic to pass through. No, you cannot do that. You cannot separate them in the physical mean already by the physical mean. The chemical reaction and the equation. Chemists use equation to describe what happens in the chemical reaction. There's one thing that you need to notice that just now there is a heat, the fire. Chemical reaction always involve the energy, heat energy. Okay. The equation saves time and space to provide the essential information of an easy to read form. The simplest equation are the word equation. Word equation is that it's using the word but without showing the ratio. The substances that take place in the reaction are called reactant. The substances that form as a result are called products. So on this is an arrow. On the left hand side is always reactants. On the right hand side is the products. You can have two reactants and two products, which is AB, become a CD. Or just like this one, you only have one, which is AB become a C. All this is iron plus a sulfur with a heat become an iron sulfate. And the arrow points from the reactant to the products. When sodium chloride solution is poured into silver nitrate, a solution of chemical reaction takes place. It produces a white insoluble solid, which is silver chloride. In the chemical reaction between the iron sulfate and the iron, and sulfate are the reactant, and the compound iron sulfate is a product. Okay. So just now the silver chloride can be done by precipitation. Precipitation means that you mix it together, and then you can see the solid is formed from the ion. Chemical name of the compound. Okay, we need to how to learn to name the compound. Chemical name can be complicated, but there are rules that how names are built out. Here are just a few examples. The first part of the name are usually name of element in the the name of an element in the compound. The second part is the name usually have the part or name and the second element in the compound. If the element is not connected to another element, the sulfate IDE may be added as in iron sulfate. Another example is the chemical name of the common salt. There is a compound made from sodium and chloride, which is a so-called sodium chloride, sodium and chlorine. If more than one atom of element joins to be an atom, the first name of the first name element, the prefix Di for 2 and Tri for 3 is added. For example, carbon dioxide. The di part name tells you that there's 2 atoms of oxygen joining with 1 carbon. And the IDE parts tell you that there are no other element in the compound. If you have more, then you will be not like hydroxide, IBE, but it's a sulfate, ATE. If there are 2 elements joined to the first element, it may be made out of the 2 names. For example, sodium hydroxide. Tell you that sodium is combined with hydrogen and oxygen. The suffix ATE is used to indicate that the second name element is also joined to some oxygen atoms. For example, the calcium carbonate means that the compound contains calcium, carbon, and oxygen. So you see here, calcium oxide is a white solid that produces a lime light. quicklime. Carbon dioxide, colorless gas. Copper oxide, a black pigment in the color to color pottery. Sulfur dioxide, a poisoner, colorless gas, produce acid rain. Calcium hydroxide, a white solid in the treatment of the sewage and the drinking water, used to make lime water for laboratory tests. Potassium hydroxide, a colorless gas is used in the soap making. Mix alkaline solution in the laboratories. Sodium hydroxide, a colorless solid used in the soap making. Again, alkaline solution in the laboratory, same thing. Sodium chloride, a white crystal solid, common salt, table salt. Potassium chloride, a white crystalline solid used in making fertilizer. Calcium chloride, a white solid, absorb water vapor from the air, used to keep the material dry. Calcium sulfate, a white solid used to make plaster or pellets. Some other are copper sulfate, can form white powder or bright blue crystal. Wow, beautiful, right? Calcium carbonate, a white solid, a compound of snail salt or egg cells present in a large amount of limestones. Last one, copper carbonate, a blue-green solid which is from the mineral core, malachite. Okay, come. We talk about mixture. Mixture is just like the green bean. You mix with the red bean. You can just pick up, go. A mixture is composed of the two or more separate substances. So they can mix a lot. Okay, green bean, red bean, peas, corns. One mixture of two substances A and B may have a large amount of A and a small amount of B. Another mixture may have a small amount of B, A and large amount of B. It depends. Okay. So the mixture can be in different proportion. Okay, but they are not mixed together. No, they are not they are not combined together. Okay. Here, there are many types of the mixture. A solid mixed with solid. For example, soils that contain clay, silt, and sand. A solid mixed with a liquid. For example, like clay and water. The clay particles are suspended in the water and make a mixture called suspension. If the solid dissolves, a solution is made. Solid mixed with the gas, which is smoke. Liquid mixed with liquid. Milk is made from the tiny droplets of oil in water. This type of mixture is called emulsion. Some paints are also emulsion. Gas mixed with a gas. Air contains nitrogen gas, oxygen gas, carbon dioxide gas, and other gases. Liquid mixed with gas. Mixed in the tiny droplet of water mixed with the air. A substance of the liquid droplets in the gas is called an aerosol. The gas mixed with a liquid. A bubble of gas trapped in the liquid form a white foam of the cappuccino. Foam can be used for shaving products and to give protection from the sun. So we talk about solutions first. Okay, the most common mixture used in the chemistry investigation is a solution. A solution is made when the substances called solid mixed with a liquid called solvent. This means that you have a cup of water. This is a solvent. You pour in some salt. Salt is a solid. You stir it. Finally, it gives you a solution. So sometimes the solid can the solid may no longer be seen, although if it is colored, it may give you color to the solution. This type of mixing is called dissolving. The solid may be a solid, liquid, or gas. Okay. So a liquid that dissolves the solvent, water, for example, is said to be miscible with the solvent. A liquid that does not dissolve in the solvent is said to be immiscible with it. A gas or a solid that dissolves in the solvent is called soluble. In that solvent, a solid or gas that does not dissolve in a solvent is called insoluble. This blue one is a dissolve. You put the copper sulfate in, you see, just see the blue solution, but no particle, solid particle there. But if you get the clay to water, it forms a suspension. But after some time, it settle and become a sediment. We have many types of solvent. The famous one is water. Water is called the universal solvent. Universal solvent. This is the keyword because so many different substances dissolve in it. However, there are many liquids that use the solvent in a wide range of the products, such as ethanol, used in the perfume, aftershave and glue. Propanol, used in the remove nail varnish and grease. Gloss paint is dissolved in the white spirit. Substances that dissolve in one solvent does not necessarily dissolve in another. For example, salt dissolve in water, but not dissolve in the ethanol. But white sugar dissolve in both. So this one, if I want you to know that to separate a sugar and salt, you can just use the ethanol. If you mix the sugar and salt in the ethanol, all the sugar will be dissolved, but the salt will be left behind as a solid. You can just filter out the solid salt. A solid does not take part in the chemical reaction when dissolved, and also can be separated quite easily. So it's a physical reaction. It's not physical, sorry, physical mix. Separative mixture. Earlier, we saw the iron powder could be separated from sulfur by use of magnet because of the iron retain its magnetic properties in the mixture. We manage in chemistry experiment the substances mixed with water or another solvent. And there are a range of processes which can be used to separate. Okay, now we need to learn a little bit of the way of separating. Number one, decanting. This is when you want to mix something like that. Can you see? There are two separate layers. You can just pour out the first layer. Okay. Large particles of an insoluble solid in the liquid settle at the bottom of the liquid of the container before a layer called sediment. The liquid and solid can be separated by this decanting. Okay. A liquid is decanted by the carefully pouring it out of the container without disturbing the sediment at the bottom. At home, some medicine and after sun lotion form a sediment in the bottom of the bottle and have to be shaken to mix solid and liquid before being used. I have a friend. I know one person that's like a friend in the seminar. Tell me that she is actually running a flower farm, okay, and produce perfume, okay, in Provence, in France. So he need to take a lot of the flour so that to boil into the water. And after some time, they filter it, and then you can see a layer of the oil, which is give you a nice smell. Okay, and then they're using this decanter so that to remove the oil and mix it with some alcohol so that to become a perfume for selling. small particles. In many laboratory experiment, filtration is carried out by folding a piece of filter paper to make a cone and inserting into the filter funnel. The funnel is then supported above a collecting vessel, and the mixture to be separated is poured into the funnel. The filter paper is made of the mesh of fiber. It works like a sheath, but the holes between the fiber are so small that only liquid can pass through them. The solid particles are left behind on the paper fiber. So what is left here is called residue. What has come out is called filtrate. Okay, a fast filter. Water funnel has hole in it. Okay. The filter bed is placed over the hose. The funnel is fastened into the top of the flask, which is connected to the suction pump by the rubber tube. The suction pump draw air out of the flask, make the mixture is poured into the funnel, and the suction pump is switched on, and the air pressure inside the flask is reduced. The higher air pressure above the mixture push it and speed out the filtration. Low pressure here so that the water will come in faster. The both type of the filtration of substance is left behind. Then you know that this is the residue and the filtrate. Centrifuge. Very small insoluble particles or in the liquid may be separated using a centrifuge. This machine has an electric motor which spins several test tube mounted on the center shaft. You see, they just turn. All the test tubes are carefully balanced by having the same amount of the liquid poured into them. As the test tube spin, the small particles are forced to the bottom of the test tube and form a layer like a sediment. When the test tube are removed from the centrifuge, the liquid can be decanted from them. Next one, separating the solid from the solvent and solid mixture. Evaporation. If a solution is heated gently, the solvent evaporates at the surface until the solid is left. Distilled water is made by boiling and condensed water to remove impurity. Tap water and seawater may be compared with distilled water by setting out sample of all three types of the water by heating them gently until all the liquid has evaporated and leave the solid content behind. And you can know who has the more salt or other things. Crystallization. Okay, this is very nice. Okay, you can add a lot of sugar or salt in your house. Okay, and to a hot water, keep boiling it. No, not boiling it. Keep heating it. Okay, and then you mix it until there are no more sugar or salt can be dissolved, and then you leave it there. Okay, and then this saturated. We call it saturated solution will later become crystallized. Okay, in some time, a few days maybe. A crystal is a solid structure with flat side. Many substances form crystal. One way of making crystal is to make the concentrated solution of the substances and then heated gently. As solution warm up, the solution evaporates until the solvent cannot hold any dissolved substances. If the heat is removed and at this time and the solution is left to cool, the substance form crystal. Another thing is called chromatography. Okay, it can be formed with a filter paper, a dropper, ink, and water. A drop of ink is placed in the center of the filter paper. Then a drop of the water is placed on the top of it. The water dissolves the color pigment and spread out through the filter paper, carrying the pigment with it. Each type of pigment move at a different speed to the other, so that they spread out into different regions of the paper. They do this because the pigment vary in their solubility and their tendency to stick to the paper. Very soluble pigment do not tend to stick to the paper, move the furthest, and pigment which are not very soluble. But be careful, this is the solvent will go higher than the pigment one. Okay, this is the thing. Then we call it a solvent front. Okay. When the separation is complete, the paper is dry. The paper with the separated pigment is called the chromatogram. Substances that do not dissolve in water can be separated by the chromatography by using other solvents such as propanol. When one of this solvent is used, the chromatography paper is closed in the tank. Okay. Just make sure that the solvent vapors do not escape. First, surround the paper, keeping the it saturated with the solvent and helping the solvent to separate. Separating a solvent from the solvent solute mixture. During the evaporation boiling, the liquid solvent is lost to the air, so you only can get the salt but not the water. If you want to get the water, then you need to do this. Okay. The first one just now, salt and water, you want to get the salt. Now salt and water, you want to get the water. Let's go distillation. A very simple distillation is like this. Okay, there's a test tube, a salt solution. Okay, this is a anti-bumping granules. Okay, so you heat it and then the steam come out, and then there's a go through a delivery tube and then go to the cold pure water, cold water tube. Okay, and to cool down the steam, and then the pure water will be, the steam will change to the pure water, which is 100% pure for the moment. The anti-bumping granule provide many places where the bubble and gas may form as the water boil. The bubbles are small and rise steadily to the surface of the liquid where they burst. Without the granule, the fewer and the larger bubble form. This rise and burst with such force that they shake the test tube. Okay. As the water boils, the steam move along the river tube. At first tube, the tube is cool enough to make some of the steam condense, but there's more steam pass along the test tube. It becomes hotter and no more condensation takes place. The cold water in the beaker helps keep the wall of the second tube, test tube, cool so that most of the steam condense and the water collect at the bottom of the tube. The solid remain in the first tube. Liquid and the gas solute are separated by the fractionless distillation. The purity of the water can be checked by the boiling it and record the boiling point. Okay, so this is the thing. So this is a thing that you need to know. Everything, for example, water. If I give you something liquid look like water, and you try to boil it, if the boiling point is 100 degrees Celsius, then you can say this is water. But if this crystal liquid look like water, but when you try to boil it, it boils it at 78, then you know that this is not water, it's something else. So in our lab, we do it with this one. Maybe condenser. Okay, this condenser is better. Okay, the condenser is a gas tube surrounded by a gas chamber called water jacket. During the distillation process, the water is allowed to flow from the top, from the cold tap through the water jacket and down the sink. The water takes away the heat from the hot vapor in the tube, the condenser, and cause it to condense. The liquids formed by the condenser vapor is called distillate. It flows down and into the collection. Okay, then usually to this one, the famous question will be like, the cool water in from the lower part and then come out on the top. It's not on the top, and then go to down. Okay, this is the most important thing you need to know. And then another one is this is called the distillate. Okay, this is last part. Okay, this is Mr. Henry Clement. If you like some notes, I always go for different colorful note, some past paper. Okay, this is today's last session. Separating two immiscible liquid. When two immiscible liquids are mixed together and left to be sent, they eventually form layers. This can be seen when oil and vinegar are mixed together with form a salad dressing. The less dense liquid form a layer above and more dense. Separating funnel can be used to separate. The tap is open and let the liquid of the lower layer flow away into the beaker. A second beaker can be used to collect. The second beaker can be used to collect the liquid from the upper layer. So this is other way than the decanting. Okay, decanting is to take the first layer first, but this one is take the lower part first. This is interesting, right? Okay. So today we learn about something called element and then the way of the separating. Okay. You may always type in the words distillation, fractional distillation, and locate online. Okay. Learning is a process. Okay. I hope that I help you during the process. This is Mr. Henry Clement. Thank you for your joining. All the best to your study, and we hope to see you. Okay. Later for the math class. All the best to you. Bye.